Hello, algebra students. For the first time, we're going to look at these equations that have variables, letters, on both sides. Let me show you what I mean. First example says solve, and we see this equation. 5x is equal to 4x plus 10. So I'm going to draw my little line through the equal sign so you can see what I mean. And this is what I want you to notice. Do you see how there's a variable, an x on this side? And there's also a variable, an x on that side? Students will try all day long moving numbers around and not be able to solve this because right now I have an x on both sides. Where am I supposed to put the numbers, right? So I always say pick a side for x. So before I start trying to isolate x, get it by itself, I'm going to get all the x terms together. Now, this is where it becomes really tricky because students will want to divide, but I want you to be careful. My goal is to move the entire term, not just the 4, but the entire 4x. I want to move over there to be with the 5x. And you could go the other way too, but this way is simpler because that side already only has an x term on it. So I'm going to move that 4x over. Now, I don't just want to move the 4. I want to move the whole 4x. And look at what the whole 4x is doing with the other thing over here, the 10. It's adding. This is a term. I need to make it 0 out. And so I either need to move it through addition or subtraction. So if it's a negative term, move it through addition. But this is a positive term, so I'll move it through subtraction. And notice I take my x with me, taking the whole term, the 4 and the x together. You say, can I do that? Can I just move x's around? You can move anything you want as long as you keep your left and your right hand side equivalent. So I will take away 4x there as well. Now be careful. Some of you guys will drop the x on one side. We're not taking away 4. We're taking away 4x in order to keep the left and right hand side equivalent. So take a look at what's going to happen over here. If you have 4x's and then you subtract away those 4x's, you've got nothing left. So there's nothing plus 10, or another way to think of it, 0 plus 10. It's really just a 10 over here now. And now 5x, take away 4x. Can you write 1x? Well, yeah, you can. But guys, we know we don't have to because 1x is just the same as x. And that, in fact, makes our life easier because if we remember that, then we can see this sucker is already solved. X is equal to 10. Now, I've showed you guys before, though. If you forget and you write 1x, it's not going to be the end of the world because you'll probably end up dividing both sides by 1 and seeing that x is 10 in another step. But you know, we're really lazy. We already know 1x is just x. And so hopefully you followed that there's really no solving to do on this particular example once I get the x terms together. All right, let's look at the next example. Negative 2z equals negative 6z plus 24. Let me draw that little line through the equal sign again so we can see. Now, again, take a look. Z on that side, Z on this side. There's no way I can get Z alone on one side until Z picks a side. Now, you might say, well, which side shall I pick? Since the only thing going on this side is Z's, it's some number of Z's, I think I'm going to say, okay, that's the Z side. That's already, everything that's going on over there. So let's take any Z's on the other side, get rid of those. Okay. Now, again, your temptation might be to want to divide by negative 6 in order to do this, but that's not going to work. That's just taking away the negative 6. You're going to leave Z behind, which is not what we want. We want to move this whole term, this whole negative 6z. And I say term because we see it in this list of things adding and subtracting. Right? We see plus 24 there. And so if we want to get rid of it, whenever you want to get rid of terms, you're going to be adding or subtracting. We want to get rid of the whole term. We're going to add or subtract. Now, which one do I choose? Well, this is a negative 6z. So we will do positive or plus 6z in order to get it to cancel out, to zero out. Now we can do whatever we want as long as we do it on both sides. So add your 6z over there as well. Z is just a number. It might be a mystery number, but it's just a number, so I can move him around like any other number. So do this in your calculator, okay, you guys, the coefficients. You won't be able to put the z into your calculator. But -2 plus 6 will give me 4. 4 what? Well, I'm adding and subtracting z's, so 4z. And that's going to be equivalent to, let's see what happens on the right-hand side. Subtracting 6z and adding 6z are opposites. They'll cancel, so I'll have nothing plus 24. Another way to think of it, 0 plus 24, or just 24. Awesome. Now this time I'm not done. I can't drop a 4 coefficient. And so I'm going to have to do some more work here to solve this equation in order to get the z alone. This 4 shoved in front is a multiplier. I'll do the opposite. I'll divide. I can do whatever I want to an equation as long as I keep the two sides equivalent. And so I'll do the same thing on that right-hand side. Multiplying and dividing by 4 opposites, they cancel. Z's alone, just like I wanted it to be. And that's going to be equivalent to what? Well, 24 divided by 4. You can pop it in your calculator if needs be, but that's 6. And now I'm done. The letter is alone. Z is equal to 6. Next example, 9b plus 22 equals 20b. Now, a lot of us just autopilot and want to subtract this 20b. There's nothing wrong with that, but it's going to make it take longer because it's going to leave nothing on the right-hand side, and then I have more to move around. So I'm actually going to move the 9b instead. Just like before, since there's only b terms on the right-hand side, I think that looks like a good place for all the b terms to go. So let me do the work to get the 9b over here, over to the right-hand side of the equation, okay? When you're moving across that equal sign, that's when you use opposites. So I'm going to subtract that 9b to get it to go away. Now I can do whatever I want as long as I keep the two sides equivalent. So I'll subtract 9b on the other side as well. See how I got all the way across the equal sign? It's nonsense if you do it twice to the same side, you guys. You're not keeping the equation equal in that case. So 9b minus 9b zeroes out, it's gone. So all I have is nothing plus 22, or just 22. And that's going to be equivalent to whatever I get on the other side. Well, 20b take away 9b is 11b. And now this is a much simpler equation here. B's picked aside. I have b over on the right, and so I'm going to be able to move the numbers on the right over to the left. So 11 is multiplying with b. I'll do the opposite. I'll divide. I can do whatever I want as long as I do it to both sides. And let's see what happens. Multiplying and dividing by b are opposites. They cancel. I'm going to have b all by itself on the right-hand side. Sorry, I ran out of room. And 22 divided by 11 is just 2. So what will b have to be? B will have to be 2. And I don't care if you write 2 equals b or b equals 2, guys. By now, I hope you know that those two things mean the same. All right, next example. 7c minus 11 is equal to 5c plus 3. So now, it looks like things have gotten a little more complex here. I have letters on both sides, but I also have terms with no letters, no variables on both sides as well. And so you might say, well, which side should I use for which? It really doesn't matter, but start by getting all the variable terms together, okay? That's always going to be my first goal when I have a letter on both sides. A letter on the right side, letter on the left side. My goal is going to be to get them together. So I think I'll move the 5c over just because I don't like negatives. So 5c, I would have to take that whole 5c away. Again, I'm not dividing because I'm taking the whole term, not just the 5, the whole 5c. And I can do whatever I want as long as I do it to both sides. Look where I write it, minus 5c. I write it underneath the c term because I can only add and subtract the same kinds of things. So that negative 5c is going to come away from the 7c's. And so I write it right underneath. Now let's see what our new equivalent equation will be. So 7c minus 5c is 2c's. And then I had this minus 11. It's still there. We haven't done anything with it. Don't lose it. And that's going to be equivalent to, well, 5c, take away 5c is nothing. It's 0. And nothing plus 3 is 3. And now this guy's a little more complex now, but you can see that I've gotten the c's to the same side. And there's no simplifying I can do on the left, right? I can't do any more work over here because these aren't like terms. This is a c term, 2c. This is a constant term, a plain old number. So I can't combine them. I can't do the subtraction. And so it's time to start getting all those numbers to go away so that I can solve. I can get c by itself. So I'm going to move anything adding or subtracting first. I'll add 11 to both sides. You think I can squeeze it in here, guys? Let's see. Subtracting 11 and adding 11 are opposites. They cancel. I got just 2c, and that's going to be equivalent to, well, what's 3 plus 11? 14. Now this is almost done. C is almost alone, but I have this 2 multiplier. I'll divide away the 2 on both sides. And multiplying and dividing by 2 are opposites. They cancel. C is alone just like I wanted to. And there's the math to do. 14 divided by 2 is 7. And so C would have to equal 7. All right, guys. So we're starting to get trickier here. We're putting our skills together. We're talking about simplifying. We're talking about solving. We're talking about combining like terms. I mean, there's a lot going on in these examples. And so, especially for you beginner students, make sure that you really are feeling fluent with these steps. Like you can do them pretty well on your own before you move on. You want to be pretty skilled at this. All right, you guys, super proud of you. Happy learning.